Good afternoon, everyone, and we appreciate you spending some time with us this afternoon to go through the latest in Precision Roll Grinders webinar series. Today, we'll be talking about precision rubber calendaring rolls and precision grinding and servicing of those rolls. We hope that you're all staying safe and continue to be safe, not only through the COVID environment that still seems to be with us, but also through all this winter weather that is affecting all parts of our country over the last week or so. But again, thanks for spending some time with us this afternoon. And we want to talk today about precision rubber calendaring and specifically about material savings with precision calendar rolls. Rubber calendars are precision equipment. You can see that list below. The rubber calendaring system has a lot of features. There are a lot of moving parts. There are a lot of dots that need to connect to one another. And rubber calendars are really, again, precision equipment. So the rolls that are in that rubber calendar need to be precision ground and precision serviced as well. It's really, truly critical for proper operation and to take full advantage of all these features that we show here. The individual roll drive motors um, uh, offer infinite friction ratios, cross-axis control systems, extrusion feed systems, automatic web centering. I'm jumping around a little bit, but hydraulic presses, mass sensoring devices, pre-tension, post-tension control units. A lot of that is predicated on having the proper rolls in your calendar that are ground properly, that have the right kind of roundness, concentricity, and shape. And we want to talk through how we recommend you partner with your roll service provider to ensure that you're getting the maximum optimization and efficiency out of your rubber calendar, and that you're minimizing the cost, the considerable cost involved in material. So what are the foundational principles? What is the calendar trying to do? First and foremost, it's there to provide a uniform sheet thickness. It's there to provide uniform roll surface temperature and temperature transfer. And then a big part of it is startup and run life as well, right? These calendars are not typically designed to have rolls easily removed and replaced. They're not typically in a spot where that's easily done. They're in the right engineering spot that makes sense for the process in your rubber facility, whether it be tire manufacturer, roofing products, whatever rubber product you might be making. So those are the foundational principles of the rubber calendar. So let's start with the first. Uniform sheet thickness really matters, right? The ability to reduce material usage by eliminating a thick or wavy sheet, and it could be thick or thin, and we talk about that in the second bullet point. Reduce defects by eliminating localized thinning in the sheet. When there is a minimum caliper that must be maintained in a web of rubber that's being calendared, then the operator, the manufacturer, has to ensure that there's enough raw material going through that minimum caliper is met. So that being said, if there's uneven shape to the rolls in your calendar, or even in the machine direction as it's going through, if there's out of roundness, in many cases where we've partnered with folks, we've seen that ends up manifesting itself in additional material needing to be used to ensure that minimum specification is met. And most importantly, improved product construction, improved performance for the end user. When the sheet of rubber that's coming through the calendar is more uniform, not only across the web from drive side to tending side, but also in the machine direction as it moves through the calendar, the better the end construction is, not only internally in your manufacturing facility where it's converted more easily because it's consistent, but also in the end product in its quality and performance for the end user. So reducing defects caused by a deviation in the sheet thickness improves the construction productivity, and obviously provides for a more uniform product. So let's look at a real world case study. This is a real world case study where the profile of the rubber being calendared, and you can see the large circle there in the center of the screen. The red profile on the left is what the rubber thickness looked like prior to precision grinding and servicing of the calendar rolls. And again, we understand one of the big concerns is, well, my calendar was never designed to have the rolls removed. We understand that. We've partnered with folks that actually have seen a significant enough return on investment that it made sense for them to actually buy spare calendar rolls and go through the effort of removing them when needed, have them precision ground so that, again, the roundness, the concentricity, and the shape is such that you can make a premier product or premier sheet of rubber coming through that calendar and putting them back in. But back to the case study, on the right-hand side, you see what the profile looked like afterwards. And it's significant savings in raw material. This particular manufacturer was able to shift the amount of raw material being used and still maintain the quality because the variability in that process had shrunk. The bell curve, if you will, got thinner, and because of that, they were able to shift it to a more optimal target range. So at the end of the day, the value needs to be proven statistically, needs to be validated statistically, and there's means to measure. And many folks have means in-house that they're measuring the variability of that that rubber web being produced. There are other means that can be utilized externally as well. But again, one of the favorite sayings around precision roll grinders is, hundreds of thousands of dollars can come down to, millionths of an inch, or tenths of a thousandth of an inch, particularly with respect to your rubber calendars. So we would encourage you again, look at the condition of the rolls in your rubber calendar and whether or not your profile looks like it does on the left-hand side in the red there or on the right-hand side in the blue. Uniform roll temperature matters as well. Not only are you trying to produce a consistent thickness of that sheet, but you're also it's also necessary, I should say, to maintain the right temperature. So temperature control reduces sheet scorching and hot spots, prevents thermal runout due to plug passages, can cause machine direction variation as well as cross direction variation. And with any kind of variability reduction or more consistency in your process, it generally translates directly to some kind of production increase that's available. Similar to what we were speaking of just earlier, the ability to shift the process because you've taken the bell curve from wide to narrow. Roll life and startup matters too. Not only does the roundness, concentricity, and shape, as we mentioned, matter, not only does the thermal properties of the roll and its ability to maintain those thermal properties consistently matter, but the mechanical and machining issues around the roll matter as well. So precision maintenance is more than just precision grinding of those rolls. It's thorough inspection of bearings and housings, proper assembly, replacing worn and damaged parts, journal repair and replacement. It all funnels into startup time and producing profitable, consistent product consistently over time as well. So again, we would ask you to consider, what does a roll roundness look like? What's the indicated run out look like in those calendars? What does the roll shape look like? Back to the previous slide on what the profile of the actual material looks like. Are the rolls concentric so that the center line of the journal is concentric to the face of the roll? And then all the mechanical issues around the rolls too, bearings, journals, housings, that kind of thing. So again, this is just a little more of a breakdown. Precision maintenance, again, is more than just precision grinding. There's closures that need to be thoroughly inspected. All the internal parts, the passages that we talked about for roll cooling, in the surface of the roll. Is the surface of the roll consistent across the face? Is it consistent across the diameter? The profile, the shape that we were talking about, and in some cases, computer controlled profiling that's utilized. You have to start with the proper profile in the roll itself. And as we had just mentioned, journals, complete repairs to just making sure that the bearing seats are concentric and are in good shape. All those things come into play. So again, work with your roll supplier to ask those questions on, okay, what does the grind profile look like after you've ground it? If you happen to be grinding in place, is there a means to show the total indicated run out after it's been block ground? What's the roll shape look like? You can utilize pie tapes and other means to measure, how are the bearings working? How does everything work together? And here's a really important piece. When it comes to the wear on a roll, particularly in a obviously in a nipped application such as a calendar stack where you're running rolls pressured together and forming a sheet of plastic or of rubber or of paper. Um, the wear on a roll is a function of its deformation, and it's not a linear function. So the closer to perfectly round you start, the longer it takes to get to a point where the deformation is such that it's affecting the quality of your product and something has to be done. So let's utilize block grinding as an example. With block grinding, the tolerances are probably around 1,000th at best. Unfortunately, with block grinding, if there's deformation in the roll, you tend to actually propagate that over time versus actually taking the roll, having it properly ground to tighter tolerances. You can see in this case, and it's a real world case, that the roll will run at a level of deformation that is acceptable to the product. In this case, 2.5 times longer, up to over three times as long, just because it's that dirt road washboard effect, right? It's when the road's perfectly smooth, it's smooth for a while, but once the washboard starts, then it escalates, and it's more of an exponential curve over time. So in this case, in 6 months, the roll deformation went from a point of starting tolerance after it had been ground to, in 6 months, reaching a regrind point because the product being produced was unacceptable. When ground to a much tighter tolerance, that obviously extended 2.5 times longer. So keep that in mind as well, particularly when weighing the benefits, the return on that investment of having rolls actually removed and ground as opposed to ground in place, or as opposed to just continuing to run them with the existing deformation. Because at the end of the day, the roll maintenance in your rubber calendar really ought to be viewed as an investment, almost like a capital investment, where there needs to be a documented return, not just a line item maintenance cost, particularly with respect to raw material savings. As we see, if we go back a few slides here, $500,000, and quite honestly, our partner told us that was conservative. So let's talk a little bit about the limitations of block grinding. Machine direction caliper cannot be optimized. It cannot achieve necessary concentricity and roundness, because again, you're almost propagating some of the deformation that's already in that roll. Without removing the roll, having the bearings removed, making sure it's concentric from the center line of the journal up through the face of the roll, making sure the shape is consistent or proper, I should say, and the roundness is where you need it to be. Block grinding cannot achieve that. It also cannot achieve cross-direction shape. Shape profile really is limited to about 1,000th with block grinding. Pardon me, that can really compound in your calendar, particularly over time, if we think about how the wear or the deformation escalates over time on that roll, the wear on that roll. And then the calendar sheet is not uniform with block grinding. It's in that leads to excess material most generally needing to be used to produce the minimum tolerances that you need. So where are the saving streams through precision roll grinding? Well, rolls ground to 2/10,000ths on bare journals so that you know it's concentric. You know that you're getting that level of precision through the web. It means correcting machine direction sheet caliper with that roundness. It's ground to proper concentricity that we talked about from the center line of the journal to the face of the roll. So it really works to start correcting sheet caliper variation, both in the cross direction and the machine direction. And again, more uniform machine direction and cross direction variability directly correlates to material savings, product tolerances, downstream converting, and really the end use customer. So, to wrap up here, because we like to keep these somewhere around 20 minutes and they all are available on our website afterwards. And we would encourage you to watch them again or to share them with folks, but your role service provider really ought to be promising you of statistically validated value. How did this roll grinding reduce the variability in my operation and therefore lead to true material savings and true economic benefit? So again, this is real life case study of what a profile looks like, quite honestly, when they're block ground for years, and then when finally the decision is made to go through the effort, and we realize that it's a Herculean effort in some cases to get the rolls out of the calendar, to have them properly ground, the proper surface finish beyond the roll, and the proper shape, concentricity, and run out be in those rolls, put them back in the calendar, and it paid for itself very, very quickly, as you can see here. In many cases, it's a matter of weeks or a couple of months before that investment in that roll grinding, and that investment in that roll service has already paid itself back, and now is putting additional savings into your operation. So how do you do that? It's pretty straightforward. It's data analysis. In many cases, it can be a predictive equation. At the end of the day, it has to lead to real economic value. So, and this can be done in many cases virtually, because we're in a virtual environment still with the COVID challenges. Our application engineering team can analyze that data. We use Six Sigma rigor when we're analyzing that data. We really do work with partners to design experiments, to measure the process, to analyze the data, to come up with improvement. In this case, the improvement of going through the effort of getting the rolls properly ground and serviced, and then controlling that over time. How long can we predict that those rolls will run with the kind of return on investment that we've seen before they have to be removed and serviced again? So again, it's really to encourage our partners in the rubber industry to have another look at the roll maintenance and the roll grinding and the roll servicing around the rolls in your rubber calendar. Keeping in mind that we understand how difficult it can be to get them out. However, if we really look at it in partnership as a investment, almost like a capital investment, as I mentioned earlier, versus just a necessary evil maintenance cost, there can be very significant return for your operation. So, as we all adjust to our new virtual partnership, we would encourage you to reach out to us. We've got historical experience doing this with rubber manufacturers. We have case studies that we can share with you. Each design of experiment is customized, so it fits your operation, that fits the end product that you're producing, and it's again customized to your operation. So with that, we're right at 20 minutes. I would encourage anybody that has questions to ask those now. There's a chat function that you can utilize to ask questions. I will also unmute everybody so that if you do have a question in person, you can ask it at this time as well. So there is one question. How long do these studies take? It really depends. If you know there's going to be a roll service, the rolls are going to be removed, taken to us, let's say for regrinding and for servicing, we can work with you to collect data that's already in your historical process that you probably already have record of, and take a look at that, get the new rolls in, take a look at the after data, and generally enough data is generated relatively quickly that you can see any kind of reduction in variability, and then start working on how to utilize a shift in your process to capture the economics behind that. So in some cases, we've been able to do that in a month, in 6 weeks. In other cases, we want to look at further length of data. So it all depends on collectively what's agreed upon with each of our rubber partners with respect to how much data we want to collect. But again, we have application engineering resources that are dedicated to doing that with our partners in roll service. Any another question? Are you internet? Yeah, we've done business internationally. This has actually been enough of a return on investment for some customers that we've received rolls out of Central America. We do rolls in rubber market and other markets out of everywhere from Southeast Asia to Central and South America, and even some out of Europe. Again, because we're talking about hundreds of thousands of dollars of savings in a relatively short period of time, in many cases, actually. Okay, are there any other questions at this time? Again, we would encourage you to reach out to your local account manager. If you don't have a knowledge of the local account manager, please reach out to us via the website, via these numbers. We do have 4 locations in the United States that are strategically located to service everyone, and strategically located in some cases to ports. Again, the effort today was to just get you thinking about how to really look at the roll quality in your rubber calendars, and how big of an effect does it have on the economics of your process and your system. Well, we thank you for your time very much. We look forward to working with you in the future, and continue to have a safe and productive day. Thank you.